Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, today we are looking at lesson 5.3.2, which is called Solving a Word Problem. And this is the first time you are going to be exposed to a problem-solving process that is called the 5D process. The 5D process is not specifically exclusive to CPM, but CPM is the program that created the name 5D, and you'll see why they call it that in a second. The 5D process is just a strategic way for you to read through, analyze, pull the essential information out of, and solve a word problem. Okay, and like I said, it is not new. It's what all good problem solvers do when they come upon a word problem and they want to make sure that they've got everything solved. And we're going to start off this process using the tried and true method of guessing and checking. Everybody knows how to do that. You don't need to have a formula for the guess and check process. All you have to do is know the definitions, and they will tell you all that information in the problem. You need to know what numbers are associated with what things and what you're supposed to do with those things and those numbers. And if you just know the basics of how to add, or maybe double a number or triple a number or do some subtraction, you shouldn't have any trouble at all with using the guess and check approach. Okay, so the 5D process is simply a process to help with solving word problems in math. And I'm going to show you a diagram in a second here, which is one that I actually created, and you'll see a poster of it in the classroom. But it's a good one for you to copy down. I would highly recommend. It's basically a flow chart. We're going to go to it right now. This is a diagram or a flow chart of the 5D process. Okay, it starts here. So I highly recommend, if I go a little bit too quickly, that you pause and you copy everything down the way that you see it, okay? And then unpause as I describe what each one of these elements are. But you want to have this in your journal. You want to use this every time you solve a word problem. You should be using the 5D process. This is not something that we just do for the last 3 lessons of chapter 5 and then never use it again. The whole point of learning how to do this is so that as you go through 7th grade, then 8th grade, and then high school, and any other problem solving that you do at any other level of mathematics, this is the approach that you will take. Okay, so it starts off with describe. This is the first D. In other words, when you're reading through a problem, could you describe what the problem is about to someone else? For instance, could you tell them what the important information is? And what is the question that's being asked in this question, in this problem? So you'll want to record all the important information about the problem. Once you've got all the important information and you've determined what the question is, then you move to defining your variables. Now, when we talk about variables, this is actually something that some of the math teachers in the district disagree on. But I'm always right, so just listen to what I have to say on this. The variables are the different parts of the problem, and they're usually being compared to each other. Sometimes people think of the variables as only the unknown quantities, but I'm going to tell you, most of the information they give you is going to be unknown, and there'll be like a couple of knowns, but your job is to figure out what all the unknown quantities are, so they're all the variables, okay? So you want to define what you know and what you don't know. What are the variables going to be? And then what we want to do is we want to see how the different parts are compared to each other so that we can reduce it to just one variable being compared to everything else. Now, right now, you are probably very confused. You don't know what I'm talking about, which is fine, because I'm going to keep bringing this up. And as you see it popping up in different problems, you'll start to make those connections, and it'll start to make more sense. Right now, I'm expecting it not to make a whole lot of sense. just write down this essential information and work through it with me for the next couple of lessons. And eventually you're going to get to the point where you're like, oh, that, yes, this totally makes sense. Okay, so once you define the variables, then you have to decide what approach, problem-solving approach are you going to take. A lot of times we use formulas, like when we are solving a problem that involves finding the area of a rectangle. You have to use a formula to solve that problem. Uh, in 8th grade algebra, you're going to be creating tables and looking for patterns, and you're going to write an equation. So you're going to kind of use all of these processes, or eventually you'll get to a point where it's like, oh, I know how to find the pattern. I don't need the table. I'm just going to go straight to the equation and solve the equation. Okay. Like I said at the very beginning, the guess and check process is where we're going to start in 7th grade, chapter 5. And we're eventually going to work toward creating, and we're going to use a table as a part of that. And we are going to eventually get to the point where we solve equations. Now, a part of the process, sometimes it's conducive to drawing a picture, sometimes it's not. So if you can draw a picture as a part of your approach, I highly encourage that. So once you decide how you're going to go about solving the problem, then you actually do it and solve the problem. See what you get for your answer. After you've solved what you think is solved the problem, you think you got the correct answer, then you've got to decide whether or not for sure that is the correct answer. So you have to check your answer. Does it make sense? Go back and look at the definitions and what you described at the beginning. When you fit all those numbers into that process, does everything make sense and work out? Feel free to use your calculator along the way. Okay, this is problem solving. I'm not assessing you on your ability to line up decimals and add or subtract decimal numbers or fractions. I want you to use your calculator for that, okay? I want you to get the correct answers, okay? And so you're checking it, and once you decide you got the correct answer, then you declare your answer, and you do it formally. Make sure that if it's a word problem, you include the words as a part of the answer. If it's a money problem, you include the dollar sign in front of the number, okay? Make sure that your answer is a complete answer. And when I say complete sentence, maybe it doesn't have to be a complete sentence, but at least more than just a random number that you're writing down, okay? So this is going to be a long lesson, by the way. I can already tell it. Hopefully it won't go too long. All right, so that's the 5D process. Pause if you don't have all that written down. We're going to move into a specific problem, and I'm going to walk you through the process a couple of times. In fact, we're going to do it 3 times in this lesson. Okay. So you have seen that being able to draw diagrams and describe relationships is helpful for solving problems. In this lesson, you will learn another way to organize your thinking as you solve word problems. That is the 5D process. Oh, and by the way, there are some resource pages that are available on the online book. They confuse me more than help me. So you do with them what you want. If you want to print it off and try and make sense of it, go ahead. But I'm not passing them out because I would rather you just copy what I do in your journals. It'll be, I think it'll make a lot more sense. All right, so here's the problem. It says, fencing the basketball court. The parent club at Post Falls Middle School needs 183 feet of fencing to go around the rectangular outdoor basketball court behind the school gym. So notice here's one side, here's another side, here's a third side, and this side has an opening for the gate. And then the fourth side is actually the building itself, so they don't need fence there, okay? So the club volunteers will only need to place a fence on 3 sides of the court because that's what I just said. All right, the length of the court, this would be the length, is 32 feet more than the width, okay? So the width is the shorter sides, the length is the longer sides. And it says that one of the shorter sides, this one, will be 5 feet shorter than the other side to leave room for a gate. So all we're doing is buying the fencing right now. Later, they're going to use something to create that gate right there, okay? So this is the problem. And we want to convey all of this information into a 5D process where we show our work and we are just feel very confident that we've got the correct answer, okay? So this, I'm going to actually put up this little screen here. Yes, okay. So the first step is to describe or draw. This particular problem is conducive to a drawing because it's in the shape of a rectangle, right? And there's a building that you're going to have here. So what we have is one side, side one would be one of the widths, side two is a second width, and side three is one of the lengths, the longest side, okay? So as I'm describing everything, we know a few things from the problem. We highlighted them. We know that the total length of the fence is 183 feet. So we want to record this as a part of the describe and draw section of the 5D process. Remember, I don't know that I said it over here in the diagram, but describe and draw go together, okay? Even though it says draw a picture down here, generally the way that the CPM looks at it, it's a part of the describe portion. That's where you would do the drawing. Okay, so what did it say about the length? I believe it said something like the length is 32 feet more than the width. And the width, you've got two different widths, right? One of them is 5 feet shorter than the other. So we've got our drawing. We've identified sides 1, 2, and 3. 1 and 2 are the widths, 3 is the length, and this is the important information that we pulled from the word problem. So now we move to the next D, which is the define section of the 5D process. And this is going to be where we start creating like a table. And you don't necessarily have to draw the table in, but you're going to find that at the very beginning, you kind of set up the information as if it were in a table. Okay, so I started this one off with it being in the table. All right, so let's define each one of our variables. Back up to the drawing. Remember, the variables are the parts that we don't know, and we literally do not know any of these side lengths, right? We don't know the width. We don't know the second one, the second side, although we do know that it's 5 feet shorter than the first side. And we don't know the length, but we do know that it's 32 feet more than the width. So this is where I start using algebra and variables. But I don't want to call this X, Y, and Z. That's going to get too confusing. So I'm going to call this X. And if X is a length that is like 50 or 40 or 30 feet, this is 5 feet less than that. So I don't know what X is, but I can call this X minus 5, right? That little section right in there would be 5 feet, and we would take it away from this one. So that's X minus 5. And then the longest side, length, it said was 32 more than the width. So here we've got our definitions. Side 1, side 2, and side 3 can be defined as side 1 is our unknown width. That's, oh, stop it. Why are you doing that? Okay, here we go again. Try again. Boom, X. Side 2 will be X minus 5, and side 3 will be X plus 32. These are our definitions for our three sides. This is going to come in handy, being able to define each one of those side lengths in terms of an algebraic expression and in terms of one variable. This will come in very handy once we start solving this algebraically using an equation. And I'm telling you right now, this whole guess and check process is not very efficient, but it does work. It is effective. What we want to be is efficient and effective, and that's once we eventually start using the algebraic equations instead of the guess and check, is where we're going to be both efficient and effective. But that's a few chapters away. All right, so let's start with the process. Now, what do we know here? When you do the problem, we know that we're doing the guess and check process, right? And we're going to make up a number, and what are we going to do with all of those numbers? We got to add them together. Because if we're going to take the total length of the fence, we got to add side 1, side 2, and side 3. Side 1, if I just randomly guess, side 1 could be 20 feet, and side 2 would have to be 15 feet because that would be 20 minus 5. And side 3 would have to be 20 plus 32, which would be 52. So we're going to take those three numbers, the 20 plus the 15, plus the 52 and add those together. And what do they have to add up to? We're hoping to add up 83 or 183 because that's what the problem said was the total length of the fence. So let's add them up. 20 plus 15 plus 52, I'll use my calculator. 20 plus 15 plus 52 gives us 87. And our fence was supposed to be 183. So this number is too low. We just decided we do not have the right answer, so we're going to choose another number. Now, I'm going to just really jump. I'm going to jump to 60. Okay? This is 60. This has to be 55 because it's 5 less, and this has to be 92 because 60 plus 32 is 92. So let's add these together. 60 plus 55 plus 92, when we add all of those together, 60 plus 55 plus 92, you get 207. And that is too high. So I know that the shortest, or the width of side 1 is some number between 20 and 60. And so we would continue with this process, adjusting our guesses until eventually we found the one that worked perfectly. And once we did, we would take each one of these and we would declare our answer. Side 1 would be this number of feet, side 2 would be this number of feet, and side 3 would be this number of feet. Okay? So we're going to move on, but eventually come back to this and find our answers. Okay? So question number 5. Now, we're not working in teams, but this is just something good for you to reflect on, okay? If another team came to look at your paper for problem 104, the work that we were just doing, could that team understand your work? Why or why not? What else would you do to make it so that someone else could make sense of your work just by looking at it? Okay, so this is the part of CPM and the part of the Common Core math that we really are trying to get students to understand. As you get older and you work in the workforce, whether you go to work for Google or you work for some other business that's not tech related, you are often working in teams. You're working together. You know, when I work with the other 7th and 8th grade teachers, we work together as a team. And so we have to, whatever work we do, we've got to make it so it's neat and presentable so anyone else that comes and looks at it will understand what we're doing. So you need to get in the habit of doing that. So what are some different things that you can make sure that you do when you're solving these problems that will make it easier for anybody else who comes and looks at your work to understand what you're doing and be able to help you, okay? Which is another good, let me tell you, I'm just going to digress a little bit, but I've had high school students come back and ask for help when they're like in 10th and 11th grade, and I asked to look at their notes. And the students that come with really clear notes, I'm able to help them solve their problems and help teach them what they need to know. But a lot of times students come and I have no idea what the problem is that they're working on, so I can't help them because they're all disorganized. Okay? So this is really important. First of all, try your best to have neat handwriting. If you're writing so sloppily that even you can't read it, nobody else is going to be able to figure out what you're doing. So be as neat and orderly as you can. Don't write too fast. Don't write too sloppy. Number 2, include diagrams whenever you can. Those drawings are very, very helpful. And other people sometimes maybe don't understand what you're trying to say in what you're writing, but if they look at the diagram, they'll know exactly where you're going. And then be very clear with your sections with the 5D process. I recommend drawing boxes and labeling your sections. This is the describe section. This is the decide. This is the do. At least for a little while, until you start to get really accustomed to how this works. That's a pretty good suggestion. But for sure, the first 2 are the best suggestions. All right. So back to the problem. While one team was working on problem 104. The team members decided to see if a width of 30 would work. Okay, so they plugged in the number 30 here, which meant that side 2 had to be 25 and side 3 had to be 62. When they did that, they added all together and got 117 for their length of the total fence. So the question is, what is a logical number that they should try next? One of the biggest problems that students have with the guess and check process is they're not doing things in an orderly, logical manner. They just pick a random number, try and scribble through it. It doesn't work, so that they pick another random number, and they just have work all over their paper. And I look at their work, and I'm like, this has got to be exhausting. Wouldn't there be a better way to do this so you could be more organized? So generally what I suggest that you do is pick a nice round number. Pick like the number 20 or the number 30 or the number 40 or the number 100. Pick a round number that's easy to work with. And then if this number's too low, remember when we chose the number 20, that number was too low? And so I decided to choose one that was 60, and that was too high. Well, 20 was too low. Turns out 30 was too low. So the next logical number probably should be, depending on how close you're getting to your total, the next number should be either like 35 or 40, or maybe 50. Choose a round number, and since this was too low, choose a number that's a little bit higher. And when we get to 60, that's too high, so now you're going to back up a little bit, right? So let's finish the process. So we know 20 was too low. When we did 20, that gave us 87. When we did 30, stop it. When we did 30, it gave us 117, right? And then when we did 60, it was too much, right? What was that, 207? Go back and look and see what that was. Yeah, that was 207. That was too high. So I think the next best number maybe, okay, what are we trying to get to, 183? 207 is way closer to 183 than 117. So I'm actually gonna not go to 35 or 40. I'm gonna go to the number 50. I think that's gonna be closer to our targeted answer. So I'm gonna choose 50. And remember, if this was x minus 5, and this was x plus 32. So we're gonna do 50, and then that would be 45, and then this one would end up being 82. So what is, in fact, I'm just going to go ahead, and this will be my do section right here, right? Let's just add those together and see what we get. 50 plus 45 plus 82 gives us an answer of 177. That is still too low. It's really close. It's only 5 away. So let's go to 51. See if this gets us there. So that would be 51, making this one 46. And then this one ends up being 83. So what do we get when we add those in? 51 plus 46 plus 83, and you get 180. That is still too low. But I think we're going to get it on the next one. We're going to do 52 plus 47 plus 52 plus 32 is 84. Let's see what we get there. I'm pretty sure this is going to be it. 52 plus 47 plus 84. That's our magic number. So the side portion of this process is built in when we go through the guess and check process. Okay, so these are our answers right here. 52, 47, and 84. So if you recall, when we do our declare, stop it. When we do our declare, maybe I'll do the declare in red because I like to give my final answers in red. Our declare is going to say that side 1, which was the first side, will be 52 feet. Side 2, which was the other short side, would be 47 feet because he left 5 feet for the gate. And then side 3 was the longest side, which is going to be 84 feet. And I like drawing boxes around my final answers. That is your declare. And here's the thing. Because you went through the 5D process so methodically and you checked your answer, you're guaranteed of getting everything right. As long as you properly declare the answer, and the question did ask us what were the three sides going to be, and as long as you included the proper unit of measurement attached to your number, it's pretty much impossible to get the wrong answer, right? Because you're not declaring anything until you finally figure it out. And you figure it out because you included the decide step in the 5D process. Oh goodness, we're running long. So sorry, it is a long lesson. All right, so let's do the 5D process for problem 109, A and B, and then we will be done. Okay, so let's do Laura. She takes very good care of her vehicles. She owns a brown van and a red truck. Although she bought them both new, she has owned the truck 17 years longer than she has owned the van. And the sum of the ages of the two vehicles is 41 years. So for the 5D process, we're not going to draw pictures of a blue van and a red truck. We can write them down. This is what we're talking about, right? There's two vehicles, a blue van and a red truck. The blue van, she bought that first, and the truck she bought 17 years later, right? Doesn't it say here that she has owned the truck for, oh no. Oh yeah, the truck. No, I got it backwards. It's the truck that is 17 years older than the van. So the van can be considered X, and this would be X plus 17. So if she's owned the van for 1 year, she's owned the red truck for 18 years. If she's owned the van for 10 years, then she's had that for 27 years, okay? So we've got the truck, which is our X. Oh no, don't do it that way. This is X plus 17. I got them in reverse. And this one is going to be X. So I'm actually, when I do my trials, I'm going to choose my van number because that's my X. So let's just choose the number 10. This one would have to be 27, correct? What is 27 plus 10? That is equal to 37, and that is too low. So let's go to, let's make this 12. So this one would have to be 12 plus 17, what is that? Two more, that's going to be 29. So 29 plus 12 is equal to 41. Boom, that's the answer. So let's go and declare how old is the van and how old is the truck? The van is 12 years old and the truck is 29 years old. There's our declare. Let's take a look at problem B. Ryan is thinking of a number. When he multiplies his number by 6 and then subtracts 15 from that number, he ends up with his original number. Okay, so we just got a number, right? And so let's just think about this for a second. If we describe what we got going on here, we know we've got a number, and we know that number is, what do? We take the number, let's go ahead and describe and define at the same time. We don't know what the number is, right? But we do know that there's a process where you take that number and you multiply it times 6, and then you subtract 15 from that number. When he is done, he ends up with his original number? When he multiplies this number by 6 and then subtracts 15, he ends up with his original number. So this is the process we're going to use. We're going to make up a number, we're going to multiply it times 6, then subtract 15, and then hopefully what we get as a result is the same number that we started with. So let's go ahead and go through the do portion of this particular process. So I'm going to make up a number. Let's make up the number 2. So we're going to multiply it times 6. 6 times 2 minus 15. And then what does that equal? That's going to be our decide portion of this. It's supposed to equal whatever that number was that we started with, right? So in this case, we're hoping it's going to be a 2. So let's see what we get. What is 12 minus 15? 12 minus 15 is equal to -3. Did that work? No, it did not. So let's try it again, and I'm going to change colors here. Let's try the number 4. If we take 6 times 4, what do we get? 6 times 4 is 24, and 24 minus 15 gives me 9. That does not work either. And this is too low, right? This is too high. So let's try it again. This time, let's go to the number 3. So what is 6 times 3? Oops, not equals. 6 times 3 is 18, and 18 minus 15 gets me back to 3. This is it. So when I declare my answer, I will say, what is the dude's name? Ryan's number is 3. And we draw a box around it to show that that is our final answer. And this here is the 5D process, okay? So I want you to practice it. You are going to get some homework problems where you get a chance to practice this 5D process. Please do your best. It will get easier. Everybody who practices this makes a few mistakes along the way, but keeps practicing it. Everybody masters this. The only people that do not master this process are the people who just refuse to do it and want to solve problems their own way. If you get right answers doing it your own way, that's great. I'm telling you, this is a wonderful process, and it's very, very effective. So I'm going to call an end to it there, almost 31 minutes, 30 seconds. All right, let's move on to our next activity. Take care, bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.